So I've made a fake data set over here. We're asked to construct a scatter plot. So what you want to do is click and drag to highlight both the names of the columns and then highlight all the data. And then in Excel, to make a scatter plot, it's a graph. So we want to hit Insert. There's a button right down here that looks like a scatter plot, a bunch of dots all over the place. And then this is the one you want. You don't want to connect the dots. Okay. So there's our scatter plot. It wants us to add a trend line. So I think I got to move things around. So if you click on the graph, this option in the top part of Excel comes up, Chart Design. You want to click Add Chart Element, and then it's a trend line, and you don't want any of the ones down here. In this course, we just do linear. So click this for, oh, you can't see it. It's off screen. Hold on. Add Chart Element, Trend Line, Linear. And there, you can see it. There's a couple of dots here that are forming a line. That's the trend line. So we've got that part of the graph completed. Yours will look different because, like I said, I changed the data set, so I didn't give away any answers. Data analysis tool in Excel to find the regression equation. And then it's this response after that. So let me help you with the regression equation. So if you have the data set highlighted, actually I think we have to type it in anyway. So let's click outside, and then I'm going to click data in the top like we usually do for data analysis. Then over to the right, there's our data analysis option. And we're conducting a linear regression analysis. So the only one that makes sense, I think, is regression. We want to make sure linear is chosen, but maybe linear is default. Doesn't say. So input Y range, that's the response variable. So we're expecting your after exercise to be predicted by your resting heart rate. Right? If a person already has a high resting heart rate, then their after exercise heart rate is probably going to be pretty high. So I got to move this chart, but I guess I can't. But I've got it highlighted underneath the screen there. I just have everything smushed together. And then the X range would be your resting heart rate. You want to click and drag. Every number there. Those two numbers should match up, 204, 204. So, I think we got everything we need. Hit OK. There's R squared. Let's see. The things you want are the things that would make the equation of a straight line. You might remember y equals ax plus b or y equals mx plus b. That's the equation of a line that we learned in an algebra course. Right? So the m is the slope. What we're given up here is the coefficient of the x variable, 0.6478. Excuse me, sorry. That's our slope. And the coefficient of the intercept is 39.14. That's like your y-intercept. The reason why this is your slope, the x variable coefficient, is because the slope is the number that's multiplying to x, right? And that's what a coefficient is in mathematics. So a number multiplying to a variable. So that's our coefficient. All this other stuff you don't really need. You might remember p-values from what we've done previously. These p-values are really, really low, and what that's telling us is that, yeah, the resting heart rate definitely helps us predict the after-exercise heart rate. Okay. Remember, low p-values mean you found some evidence for some sort of effect happening. Okay, I think that's it. The rest of it is interpreting the results. Let me see if there's any hints I need to give there. Graph scatter plot, we did that. Linear relationship. Does it appear to make a straight line? Does the scatter plot seem to make a straight line? And what does that mean? That would mean, if it does make a straight line, that means the two variables are related to each other in a linear nature. As one goes up, the other one goes up by some constant value, roughly, on average. If the dots are all over the place and you can't find any pattern, that means the two variables are not related to one another. They don't affect each other. Calculated correlation coefficient R using Excel. That came out, the R squared came out of our analysis here. So R would just be the square root of this value. Or here's another way of getting the correlation coefficient. If you go back to your data set, you could just type in equals correl, open a parentheses, and then click and drag X column with correlation coefficient, doesn't matter the order. Click and drag the X column like I did, put a comma, and then click and drag the Y column. Okay, but like I said, this is going to be the same value if you just take a square root of R squared, 0.6698. That's the correlation coefficient. You can get the same value from the R squared. I've got 0.491367. That's probably enough. Take a square root. Oh, and it is a little different. Maybe I accidentally put a cell with 0 and 0 in it. But they're really close. They should be the same. It's probably just because I have my screen shrunk and I accidentally put an extra cell of blank cells in there at the bottom. But in practice, those should be the same. Okay, so you can just take a square root of that number, and that will get you your correlation coefficient. I think that's everything. And so is the relationship strong? A linear relationship is strong if R is close to 1 or it's close to -1. If R is close to 0, then it is a weak relationship. Okay, and then the slope we already talked about. What does the slope indicate? What a slope tells you, it tells us that our exercise heart rate goes up by 0.6478 units for every 1 increase in our resting heart rate. So if a person has 10 more beats per minute for a resting heart rate, we expect 10 times 0.6478. We expect 6.478 more beats per minute for their after exercise heart rate.